We've got a really cool automated metrology demo to show you just over there in a little bit. But first of all, I'm here with Nicky. ACCRETECH, really big metrology company. Some people might not know much about them. Who are they?
So, ACCRETECH, established 1949 in Japan, formerly known as Tokyo Sumitsu. Obviously, we're called ACCRETECH. ACCRETECH is the Western name. Like I say, we've been going since 1949. People commonly know us through our business partners of the past, but since a few years gone by, we set up a UK point for contact for the Western customers, including our head office Munich. From that time, we've gone from strength to strength and grown exponentially over the last few years to the point where we're expanding continuously.
Brilliant. That sounds pretty scary. Exponential growth is pretty huge. You've only got 2 products here, unfortunately. You've got a massive portfolio in the wider world, haven't you?
Absolutely. So, well, the point of today is to bring a couple of products suitable for the FANUC audience. So, the portfolio in general, we cover everything from tooling run-out detection, dynamic balancing systems for grinders. We supply the majority of OEMs for the machines. So here we're looking at right now, we're looking at the RD10 tooling run-out detection system, which is just here. You see the control unit that connects to a typical robo drill. Now, this tool run-out detection system basically looks for vibrations in the tool when, for example, you've got swarf contamination in the tooling holder.
So you've got some kind of proximity sensor here that looks at the flange on the
Absolutely. So we've got a little sensor there. So basically, when the tool's inserted, if the coolant flush hasn't been successful, the tool could be slightly running out.
Spin the tool around like this.
Yeah. so in effect, the tool can do this basically. And if you're machining a hole, that hole could be slightly larger. So if you've got an engine block in production and your holes are slightly out of tolerance, this is not a good thing. And
it's not quite going to work, is it?
No, so the scrap levels could go up quite significantly. This system you can connect it via Ethernet and control many systems, as we have got in the field in the UK already, and basically process control and scrap reduction. So a lot of customers use this remotely so they can see what's happening in their tool and literally put a critical moment in if a tooling run out occurs, so they can stop production, change the tool, get it cleaned out, replace the tool if necessary.
And I guess automotive is a really good example here because they're doing real huge volumes. It might not be used by a job shop doing 1 or 2 parts a day,
Absolutely.
but high volume, you need to get that real 99.999% process control.
Absolutely. And that's the core aim for this product. But if you do have a single, very expensive component with multiple tool changes, and you are machining the likes of aluminium, etc., where the material is quite soft and sticky in compared to, say, Inconel, let's say, this becomes quite critical also in high-cost single components. And customers are realising this, and they're realising the cost savings also.
Yep, tool run-out is a real big issue with tool wear, with part quality, vibration even. But enough about tool wear, we've got a really cool demo here doing something that quite a lot of people actually, they're not doing yet in their machine shops.
No, so this is something else we wanted to demonstrate because it's not typically seen by the UK audience in particular. So stereotypically, we have here, just to go over, we have a FANUC cobot feeding a radial measurement machine. So this is metrology, the science of measurement. Our customers, the more discerning customers at the higher end of the market where their components are basically sub-micron, will use these radial form machines to check the form and geometry of the components. What we're looking here, you can measure the component in maybe, let's say, 10 mil in 2 points. But when you measure the component over 14,400 points, you might realise...
And that's around the whole diameter?
Yeah, absolutely. It will go round. And the beauty of this machine, this Roncon machine here, is that we can measure planes, bore cylindricity, coaxiality, perpendicularity of axis to a plane. The list goes on.
We're looking at, I mean, you mentioned off camera a lot of automotive examples like crankshafts and axial products.
We have iterations. This is just one machine of many in our surface form and geometry portfolio. This is a radial machine. We also do surface form and geometry. We have customers, for example, that will measure on a very different machine to this, but fundamentally the same functionality. We'll measure engine blocks, crankshafts. They'll look at surface finish of piston bores, measure the pistons, anything you can imagine, right down to silicon wafers, looking at node paths on our surface finish machines. We can check the form. So
that's some really small stuff.
Yeah, so it's proper nanometer stuff. So we're quite proud of these machines, being, you know, some down in the nanometer, some sub-nanometer range if you've got deep enough pockets, right down to the crude 24/7 CNC production, but at the sub-micron range. So the point of us being here today at FANUC and being quite proud is showcasing what is stereotypically reserved for the standards room or an inspection room. Basically putting a collaborative robot offering a lights-out solution to something that is fundamentally an item that really hasn't been available before. So we've picked a machine that generally you would never see with a robot, but people would love to, because it's a lot of time for the operator to be standing at the machine.
Completely. I mean, depending on the kind of components you're doing, some need to be inspected every single one, not just 1 in 10 and 1 in 100. If you need to inspect every single one, maybe it's a new contract, you've never had this kind of tightly tolerance component before, suddenly this thing becomes your bottleneck.
Absolutely, and that comes down to takt time. So obviously you look at takt time through a process. When you're measuring high quality, high precision components, quite a large part of the component takt time is actually the measurement and inspection, and the intermediate operation inspections that you have to carry out whilst mid-process. And it's quite common, if you haven't got this kind of thing in process, where an operator will walk away from a machine.
Yeah. So leave it idle.
Leave it idle. Rather than having a palletized system, we have some system where you palletize it, put it on, and then the flow's constantly running. And this is the key aspect, and this is what we want to demonstrate.
I'm going to ask a bit of a challenging question here. I hope that's okay. Sure. I'm interested. Some people will say, well, I've got on a first article inspection on a component, and I can't run any more of the batch until I've got this first article inspection finished. I mean, how do you solve that? Sounds like an unsolvable problem. How do you deal with that?
The trick is speed.
No, that's a tough one.
The trick is speed. So you have your systems pre-programmed ready. So our systems, although they're high accuracy metrology pieces of equipment, they are full CNC capable. So you can have a program rewritten for separate operations. So the operator stroke programmer, which generally are in these style of products, could place it on, literally press the button, go and prepare his next piece. While he's preparing the next piece, he can walk back, see the good, no good, variation, offsets required. Then he's got his next part prepared whilst taking the other components straight back to the CNC machine, and he's good to go.
You need to shave off those times in between, because you can't run the machine while it's doing the first article inspection, but shaving those times in between is really important.
Yeah, every process is different, and there's always different amounts of time to shave off different places, but let's go for the big one.
Yeah, perfect. Let's try and shave some more time by using automation on CMM machines, all these really fantastic sub-micron and micron machines. Super accurate from ACCRETECH. Thank you very much, Nicky. That's it, we're moving on.